continuation of the topic of acids, bases, and salts. And we are done with the topic of acids and completed the topic of bases as well. Right now, with the topic of oxides. Before moving towards oxides, we are going to deal with few smaller points which will help you to understand the basic concepts related to many topics. Okay, so number one is oxide. For example, what is an oxide? Okay, it is an element of periodic table. Obviously, an element plus oxygen is called an oxide. Okay, then there is another term that is called halide. Okay, so it is an element, and along with that element, if there is any halogen, then that is called as a halide. All right. Then there is another that is a hydride, and might be the name is clarifying. It is an element plus hydrogen. Okay, plus hydrogen. Whenever any element of the periodic table is attached with hydrogen, it is called as hydride. Okay, then there is a sulfide. It is an element plus sulfur. An element and it is attached with sulfur. Okay. And then there is another term that is phosphide. Phosphide. Okay. So an element when it is going to attach with phosphorus. Okay. So this is called as phosphorus. Okay. So this is called as a phosphide. Then it is oxide, halide, hydride, sulfide, phosphide. There is another term which is called as nitride, and nitride is also called as azide. So whenever an element is attached with nitrogen, then that is called as nitride or azide. So this is how we are working on these basic concepts. Right now, only the details of oxide are part of your syllabus. And now we are going to discuss about that. Okay. So there is one more term which I would like to tell you, that is carbide. Okay. So it is an element, okay, attached with carbon is called as carbide. Okay, so for example, we can say methane is one of the carbide. How it is a carbide? It is a combination of hydrogen with carbon. Okay, but parallel it is a hydride as well. So it is a hydride of carbon. Okay, so it is a term like that, in which we are basically going to have this information, that how elements are going to make attachment with each other, and how we can judge that which elements will be present in this. Okay, so if we are saying that it is a hydride of carbon, so it means that it is a combination of carbon with any element, which is hydrogen definitely in this case. Okay, so it is a halide, so it is any element and which is attached with halogen. Okay, so this is how we can have a basic idea. These terms are not very much detailed information givers, but they are just telling you a basic concept that these elements are present in this. So oxide term is just telling you that oxygen is present in it. Halide term is telling you that any halogen is present. Hydride is telling you that hydrogen is present. Sulfide is telling you that sulfur is present. So this is the basic concept which we can take from these terms. So right now I'm going towards the details of oxides, and remember this thing, that only the details of oxides are part of your syllabus. We are going to discuss the hydrides of carbon. When we will discuss organic chemistry, all alkanes are hydrides of carbon, all alkenes are hydrides of carbon. So what are alkanes and alkenes? These are the terms which we will use while studying organic chemistry, inshallah. But right now our focus is on the terms of oxides. Okay. So oxides are basically, I'm saying you that it is of how many types. So basically, there are four different types for oxides. Okay. So number one is acidic oxide. Number two is basic oxide, and number three is amphoteric oxide. Let's discuss acidic oxide. and number 2 is basic oxide. Number 3 is amphoteric oxide, and number 4 is neutral oxide. Okay, so these are oxides and these are the types of the oxides as well. So please look into the fact that these are the 4 types. Okay. So right now we are moving towards the term that is called as acidic oxide. Okay, so acidic oxide are basically oxides of non-metals, oxides of non-metals with oxygen. They are called as acidic oxide. Okay, so for example, we can say oxide of carbon dioxide. We may consider oxide of carbon. One of the oxide of carbon is carbon dioxide. Carbon dioxide is considered as an acidic oxide. Okay, then P2O5, it is a phosphorus oxide. There is another formula of this, and that is P4O10. So these two formulas are telling you that these are the oxides of phosphorus. Then there is another that is called as sulfur dioxide, sulfur trioxide. So there is nitrogen dioxide, etc. These are the oxides of non-metals, famous oxides of non-metals, and these are, you may say, uh, making acidic oxide category. Okay, so right now we can say this thing that what are the basic properties of these oxides. Let's go on to a new page. Okay, so let me add few pages. Okay, all right. Okay, so we were studying acidic oxide and we have given the examples. Now acidic oxide, acidic oxides soluble in water, and then what they are doing, making respective acids. For example, when carbon dioxide will be dissolved in water, it will make carbonic acid. When sulfur dioxide will dissolve in water, it will make sulfuric acid, initially sulfurous acid. And when this sulfurous acid is combining with more oxygen, it is making sulfuric acid. So H2SO3 is called sulfurous and H2SO4 is called sulfuric. Okay. And for example, there is one more, nitrogen dioxide is combining with H2O, making HNO2, that is called nitrous acid. This nitrous acid is combining with, again, combining with oxygen again, making nitric acid. So these acidic oxides are combining with oxygen and they are making respective acids. Okay. Now I'm changing the page. So whenever an acidic oxide, as it has an acidic property, so here I'm writing acidic oxide is combining with a base, as a result, what it is making, it is making salt and water. Okay, so this is how this reaction is happening. Let's discuss few. For example, when carbon dioxide is, okay, instead of making taking carbon dioxide, because carbon dioxide is a common example of a gas, we will discuss about carbon dioxide as well. Let's discuss about NO2. For example, when NO2 is reacting with NaOH, it is making NaNO3 along with water. Okay, then similarly SO3 is combining with NaOH. Okay, we can take any other, for example KOH. KOH, it is making K2SO4 plus H2O. Okay, these equations are not balanced, so you can take it like that. For example, So this is just telling you that how we have to balance a chemical equation. It is compulsory to make an equation balance. So these are the examples in which we can say this thing, that these oxides are reacting with bases. Potassium hydroxide and sodium hydroxide is a base, and they are combining with oxides of non-metals to make salt and water. So these reactions are called as neutralization reactions. Okay, neutralization reactions. Okay. So if there will be any equation which you are going to find that it is not balanced, you can balance the equation. Or if still you are finding a problem in balancing of a chemical equation, you can send me a message. I will definitely help you, inshallah. Okay, there is one very different type of an oxide, and that is called as SiO2. Okay, so what is the property of SiO2? Let's discuss that. Okay, it is considered as an acidic oxide. Okay, one of its property is matching with acidic oxide, whereas the other property of silicon oxide is not matching with acidic oxide. What is matching and what is not matching? For example, number one, it is insoluble in water. It is insoluble in water, whereas all acidic oxides were soluble in water. So this property is not matching. But which property is matching? It is reacting, it is reacting with bases, with the bases, hence show what show hence show neutralization reaction, hence show neutralization reaction. Okay, so for example, what is the reaction here? It is making sodium silicate, for example, SiO2 is reacting with CaO, you may say, and it is making calcium silicate, CaSiO3. Okay, calcium silicate. This is a famous reaction. Where we will study this? We will study this in iron extraction, inshallah. Calcium silicate. Okay. In one paper, examiner is asking what is the charge on the iron, or write down the formula of silicate ion. Okay. So how student will know what is silicate ion? Guys, this was the formula CaSiO3. Okay, Ca has a charge of +2. Why? Because it is a part of group number 2. So that's why it has a charge of +2. What about the remaining part? This remaining part has this formula SiO3, and definitely its charge will be opposite and equal. Okay, so that will be called as the silicate. Silicate ion. Okay, silicate ion. It will be considered as a radical, as it is a polyatomic ion, more than one atoms having a collective charge. So silicon dioxide has a dual type of a nature. We cannot say it has a dual type of a nature. We should not say, actually, because it's none of the properties matching with bases. So it is reacting with bases just like acid. So this reaction is considered as a neutralization reaction. We can say this thing, that this is an acidic oxide because it is reacting with bases, but its one property is not matching with acidic oxides. And what is that property? It is being insoluble in water. Okay, so now I am taking you to the next topic, and that is called as the basic oxides. Basic oxides are the oxides of metals, basically. These are metallic oxides, you may say. Okay, so examples of metal oxides are copper oxide and Na2O and CaO, etc., etc. Okay, CaO. Now the point is this, that there is some different property of basic oxide. And what is that? Some of the basic oxides are soluble in water. Basic oxides, some are soluble, some are soluble, whereas some are insoluble. Some are insoluble. Okay, so the ones which are soluble are combining with water, and they are making an alkali. Okay, an alkali. Now the point is this, that when they are making an alkali, they are behaving like soluble bases. Okay, so which of them are soluble and which of them are insoluble? Group 1 and strontium along with barium, their oxides are soluble. So we can say this thing, oxides are soluble. Okay, so now we can say this thing, that in this way, if we are looking into this categorization, then Na2O, SRO, BaO, K2O, etc. are soluble. But is there any example which are insoluble? Yes, we can take another example. For example, CuO is insoluble. For example, for example, you may consider something which is the part of, for example, you may consider beryllium oxide is somehow, or instead of beryllium oxide it is good to take lead oxide, okay, or lead oxide is also in another category. So we can take the example of tungsten oxide, for example, tungsten oxide is also considered as a metallic oxide, but it is insoluble. So only the oxides of group number 1, strontium and barium, are soluble, and rest of the oxides of the metals are insoluble. So they are basic oxides, but they are insoluble. Okay. So the point is this, that if we are moving on to a new page, we can say this thing that basic oxides acids plus acids, what they are giving you? Neutralization reaction. And I am going to give you 2 or 3 examples. For example, Na2O is reacting with H2SO4 and giving you Na2SO4 along with H2O. I am giving you another example, CuO plus 2HNO3. It is giving you copper nitrate along with H2O. So these are the 2 examples in which acids are reacting with basic oxides. Okay, so these are the 2 examples in which basic oxides are giving neutralization reaction while reacting with acids. Okay, so this is how we can say this thing, that acidic oxides are acidic in nature, so they react with bases just like acids. Basic oxides are basic in nature, so they are reacting with acids just like bases. So this is how we are going to discuss such type of the reactions. Rest of the 2 oxides are still at the back end, and we are going to discuss them in the next class, that is amphoteric oxides and neutral oxides. Okay, all the best.